Okay, year 12, calculus. I will just run through the graph at the top of page 17 in your 2.2 graphs booklet. Okay, it looks a little bit like the cross section of a skateboard park, like that. Okay, and for each part of this, we need to give an equation and talk about things like domain and range if you want to get full marks. Okay, now I've made a quick sketch of the skateboard park, as you can see. And the first one we're going to look at is this one here, this line here. Now this is a horizontal line, but it stops there. Okay, so this is a straight line, and it has the equation y equals 3. Now y equals 3 goes all the way along like this through 3 on the y-axis, like that. It's a horizontal straight line. Now, when you talk about the domain, as I've shown you here, one of the good ways of writing it is like this, but you must say it in the correct way. You say it like this. The domain, now we're talking about this straight line here. The domain is all values of x. Now these 2 points you should read as such that. Okay, so let's do it again. All values of x such that x is less than or equal to -6. Well, x has got to be less than or equal to -6. Well, there's -6 there. So it means that all those x values below -6, the line can be drawn for those, but it stops at x equals -6. So this statement here says that all the values of x are in the domain such that x is less than or equal to -6. The range, you're looking for the y values for which this can be drawn. Well, it can only be drawn for the y value of 3 because it stays 3 all the way along here. Okay? So the range is just y equals 3 only. Okay? Now let's move on to the next curve in the skate park. It's this one here. Okay, now this one here just touches the x-axis at this point here. Okay, now I'll move that up and see what we can see. Let's see if I do it like that. That's better. So if it's just touching the x-axis, we know that it's going to be we are going to be able to write the equation like this. It's going to be x plus 3 because this is minus 3, so it's the original parabola gone 3 units in the negative x direction, so we write a plus sign there. But it's the same, it's the brackets all squared. This is really x plus 3 in brackets multiplied by another x plus 3 in another brackets. But of course, if those two brackets are the same, we can just write a little squared there. Now, when we start the equation like that, we don't know what k is. So we use a point through which the curve goes. Now, the point I've used is this point here, where it cuts the y-axis, or it finishes at the y-axis at 0, 3. So I'm putting 0, 3 into the equation. There it is, 0 for my x, there it is, 0 there, and my 3 is for the y there. So now I work this out for k. Well, 0 plus 3 is 3. 3 squared is 9. So this is 9. And I'm going to cross multiply the 9 to give me 3 over 9. So k is equal to 1/3. So you put that 1/3 back into your formula and you write the complete formula like that. So that is the complete formula for that parabola. Okay? Now, you need to talk about the domain and the range and any other features of the graph. Well, the domain, you can see the x values go from there to there. In other words, this parabola only exists from x values from there to there, and that's what you're really stating in the domain. So you write all the values of x such that minus 6, that's that minus 6 there, is less than or equal to x, which is less than or equal to 0. So this is stating the values of x for which this parabola can be drawn. That's the domain. The range, looking at the y values. Okay, there are no y values down here, for which this can be drawn. There are no y values above 3 for which this parabola can be drawn. So you've got to state that. So that range, you read it like this: all values of y such that 0 is less than y, which is less than or equal to 3. Okay, there it is. 0 is less than y, which is less than or equal to 3. So this is stating that y is in that range of values from 0 to 3 there only. Okay, and we need to mention that there is a y-axis intercept at 0, 3, and that it touches the x-axis at -3, 0. So it's really like the x-axis is a tangent to the curve at that point there. So these are some of the important features of this bit of the parabola. All right, now I have to zoom out and go to the next picture. So just bear with me while I do that. And bingo. Yes, here we are. So let's zoom in and talk about this. This is a bit of a tricky one, this. I warn you. All right. Now, let's get rid of all of this. Okay. Now, this is the part C of the graph. We can't see it on my screen here, but I'm sure you can see it in your book. It's just after the y-axis where that previous parabola finished. Okay, so it's obviously an upside down parabola, so we call it a negative parabola. And it's got a vertex or a maximum at 1, 4. So if it's got a maximum at 1, 4, or vertex at 1, 4, it makes sense to use the vertex form of the parabolic equation, the quadratic equation. Okay, so we put in to the brackets squared, there is the x coordinate, but with the opposite sign. This here is +1, so we're going to be writing -1 there. So it's there, that's going to be squared. And this y coordinate is at the end here with the correct sign plus. Okay, so this is the vertex form of this parabola, but we don't know what k is. So I'm using the point where it starts on the y-axis, 0, 3. So 3 is for my y, and 0 is for my x. And now I work out what k is. We'll take the 4 over the equal sign, goes to -4. -1 with nothing taken away or added just gives you -1, but this -1 is squared. Well, if you square -1, you get +1. So this is really 1k is equal to this thing here, which comes to -1. So it is -1 for k. So the full equation, or the complete equation, is y equals -1. We don't bother writing the 1 in. Brackets x -1 all squared plus 4. Now, when you look at your graph, you can see that this tiny fragment of the parabola, okay, it exists for all values of x such that 0 is less than x, which is less than or equal to 2. Okay, you should now be able to see that on your graph. The range, well, It only exists between 3 and 4 on the y-axis. So that's what you've got to state. All values of y such that 3 is less than or equal to y, which is less than or equal to 4. And that there is a y-axis intercept at 0, 3. All right. Now we get to the really difficult one. Okay, D. Now, D is a negative cubic. Okay, it only exists in this little fragment up there. Okay, now what I've gone and done is I've made a little sketch and I've imagined where that cubic would have started life somewhere here at the origin. So this point here in this original type of negative cubic like that has gone from there to there. Well, if it was there, then how would we write its formula? Well, what we would say is this. Look at this top line here. We would say that y is equal to k, x plus 1 for this, where it crosses the x-axis there, x plus 0 for where it crosses there, and x minus 1 for where it crosses there. Okay? So if the cubic was like that, we would be writing a formula like this. However, this cubic here has been moved 3 units in that positive x direction and then 3 units up. Well, if it's going to be moved 3 units in the positive x direction, it means that in these brackets here, there's going to be a minus 3 in every single one of the brackets. So this x plus 1, you've got to have a minus 3. For this one here, you've got to have a minus 3. And this one here, you've got to have a minus 3. But don't forget that on the end, you've got to have a plus 3 because it was shifted up plus 3 units that way. So when you do that, this, of course, becomes x minus 2. This becomes x minus 3. And this one here becomes x minus 4 with the plus 3 at the end. Now, so you do that, this minus 3 for each one of those brackets, and that shows you now that this thing here, this cubic like that, has been shifted 3 units that way and 3 units up. Okay, now there is a problem. The problem is that if I use any one of these coordinates, that one, this one, that one, that one, these ones lying where x is 2 or 3 or 4, if I put 2 or 3 or 4 for x in here, it's going to make all of that 0. So it's not going to work. So you've got to use this point here, which is at 2.5 for x, 2.5 for y. And when you do that, you get something that looks pretty fearsome, but it actually, you work it out clearly, it comes to this here. You put 2.5 for y, and for into that formula you found here, for each one of those x's, you write 2.5, 2.5, 2.5. Don't forget your plus 3 on the end. Then, if you take your plus 3 over, it goes to minus 3. This goes to a half. This bracket's minus a half. This bracket's minus 1.5. Multiplying them all together gives 3/8. Okay, positive, because minus times minus gives 3/8. And play around with this, and you get k is equal to minus 1 1/3. Okay, put that back in the formula, and there is your k value there, and there's the original formula. I'm about to run out of time, but there is the domain and range of that cubic. Okay, now I will finish off this skateboard in another video following this one. Thank you.